Welcome to Lecture Online. Our next topic in vectors is components of a vector. So what do we mean by that? Well, notice here I drew a vector, a force vector, and notice that it's not pointing either in the x or the y direction. It's kind of at an angle, and we don't know what that angle is at this moment. But notice that I can project my vector onto the x-axis by drawing a dashed line from the tip of the vector straight down. And I can project the vector over to the y-axis by drawing a line horizontally to the y-axis. If I then draw two different vectors, one that is parallel to the x-axis, one that's parallel to the y-axis, from the origin, from where the vector, the force vector started, to the point where the vector projects on those two axes, I draw one vector this way, and I draw a vector this way. These two vectors now, because they're vectors, they have a magnitude and a direction, so they're vectors. Those are now called the components of vector f. And this vector, which is along the x-axis, is called the x-component of the vector. So let me write that down. That's an important term, x-component. And I can write this as f sub x. Of course, I still need to draw a little arrow on top of that, because that's still a vector. A vector has to have a little arrow. And here I can write this as this is the y component. And so I can write this as f sub y like that. So here's the x component, the y component of vector f. And f can now be written as the sum of its components. So I can say that f is equal to the x component plus the y component of the vector, simply as the sum of the two components. Now, the x component has a magnitude of 4, and it's in the x direction, so I can write that as follows. I can say f, therefore, is 4 newtons in the x direction, so that's how I write that component. And the y component is 3 units in the y direction, so I can put plus 3 newtons in the y direction. And this is the proper notation of how to write a vector as the sum of its components. So here I wrote the vector f, the force, as a function of its x component and a function of its y component, or simply as the sum of the x component and the y components of the vector. All right? So now we haven't shown you yet how to find those components if you're given the vector. Now also notice that the magnitude of this vector here can be found by using Pythagorean theorem. Another thing you should know is that we can take vectors and move them anywhere you want. So I can take this vector and I can move that vector over here. It doesn't change the vector in any way because it still has the same magnitude and it still has the same direction. So let me use purple. Hopefully this pen works. There it is. So now what I've done is I've now moved this vector over here, and I haven't changed anything. It still has the same magnitude, it still has the same direction. So it looks like vectors don't depend upon where they're situated, only in which direction they're acting and how big they are. Now notice I have a triangle here, and using Pythagorean theorem, I can say that the magnitude of the x component squared plus the magnitude of the y component squared should equal the magnitude of the vector itself. Now, if I want to represent the magnitude of either a component or of the vector itself, I can do this as follows. I can say that f, without the arrow, simply talks about the magnitude of that vector. And this is equal to, notice what I've just done. I've taken the vector notation of the vector f, and I put little absolute value signs around it, and this simply means the magnitude of the vector. And this can be found by taking the square root of the square of the magnitudes of the components. I can take f sub x, which is the magnitude of the x component, not the direction, but only the magnitude, squaring that, plus the magnitude of the y component and square it, sum them together, take the square root, and that gives me the magnitude of the vector f. So this can be written as the square root of f sub x, we said was 4 newtons, so we take 4 newtons, and we square that, plus the y component, which is 3 newtons, and we square that. Now notice that would be 16 newtons squared plus 9 newtons squared, which is 25 newtons squared, so this is equal to the square root of 25 newtons squared. And when I take the square root, I get 5 newtons, and so there you find the magnitude of the vector f. So I can write that f is equal to the vector f with absolute value signs around it, which is still the magnitude, which is equal to 5 newtons. So this says that's the magnitude of that vector. And of course, the direction would be at an angle away from the origin at an angle theta with respect to the x-axis. At some later time, I will show you how to find that angle. But at least now we have an idea of how to talk about the components of a vector. And notice that if you add the two components together, you get the original vector back. That is that.